Hello my dear students, welcome back to the session. 18th question, we stopped in last session at 17th question, classroom workbook you can see, is asking what is ZXY. A similar problem we have done in terms of ABCD parameters, okay. Now let's see in terms of Y parameters. In the last session, I think 16th problem or so, we have done ZXY. Two-port networks are connected in what? Cascade, but with Y parameters. But this two-port network is open, this two-port network is shorted here, second port side, here primary, first port side, okay? First port side open and expected to determine ZXY here. We already know Z and Y relationship. We already know that. I'm just writing here once again. If you want, you can note down this. Z is equal to Y inverse and Y is equal to Z inverse. You can already find the Z is equal to Y inverse. Y inverse is nothing but what? Del of Y, Y11, Y22 minus Y12, Y21. Y22 by del Y, Y1 by del Y minus Y12 minus Y21. Similarly, even Y is nothing but Z inverse. You can find. So these relations must be on your fingertips, right? Now let us look at ZXY. What do you mean by ZXY? With respect to XY terminals, how these two-port networks are connected? Parallel, yes or no? So if I say this is Z1 and this is Z2, so definitely ZXY is nothing but Z1 parallel Z2. It's something like this. I already told you in the last session. I think in the 16th problem, we have already done that part. So something like this. This is Z1, this is Z2. With respect to XY terminals, now this Z1 and Z2 are connected in what? Parallel combination. So what is Z1 actually here? Z1 is nothing but this is what first two-port network, right? So Z2 dash of network two-port network 1 of open circuit, because this is open terminals. So how do you define it? V2 by I2 when I1 is 0. This itself is Z22 of first two-port network. Understand? This is the first two-port network. TPN1, TPN2, two-port network 1, two-port network 2. Okay. But you are given Y parameters. So what is Z22 actually here? Z22 is nothing but Y11 by del Y. Agree all of you? Okay. Well, now Z2 is nothing but what? Z2 is nothing but what? Okay. What is Z2 actually here? Z2 is, okay, Z11. I just write here Z11 dash of short circuit of two-port network 2. That's nothing but V1 by I1 when V2 is 0. Understand? Okay, when V2 is 0. But already when V2 is 0, I1 by V1 is defined as what? Y11. Okay, under short circuit condition, I1 by V1 is nothing but what? Y11. But here you have V1 by I1. Therefore, 1 by, you can say, Y11. You understand all of you, okay? So what is ZXY from this? Z1 into Z2, that is nothing but Y11 by ZY into 1 by Y11 by Y11 by ZY or del Y, okay, plus 1 by Y11. Now you will get here, okay, you will get here, these two get cancelled, and finally you are getting with Y11 by Y11 square plus del Y. Okay, this is what ZXY. Please note down. Please note down. I remove this part. You already know these formulas. I think you have noted down. 19th problem. I read this problem. Find V1 if the following two-port network is reciprocal. Okay. Only one two-port network is taken, but different conditions are applied. Okay. The two-port network is same. This is figure 1. This is figure 2. But network is same. Two-port network same. It does not change. Find V1. He's asking V1. Find V1 if the following two-port network is reciprocal. This is 10 volts given. Okay, figure 1, figure 2. There are some two conditions given. Okay, or let us say some experimental data is given. When this is shorted, when ammeter is connected here, ammeter is connected here, and voltage source is connected here. This is what the scenario. Now he's saying that when the voltage source is connected here, V1, what is the value of V1? Okay, and he's giving a condition that the given two-port network is reciprocal. Okay, so think of. Okay, so here the data given, look at this. This is 2 dash terminals, right? This is also 2 dash terminals given. 1 dash, 1 dash. So what is the data given actually here? In the first case, I2, I1, V1 given. In the second case, V2 given, V1 is asking. Understand? Okay. So what is V1 is asking? In the first case, in the first figure, you are given I1, 10 amperes, I2, 2 amperes, and V1 is 20 volts, and V2 is 0. So short circuit condition is given. In the second case, I1 is given 0 because the open terminals. Okay, this is from figure 1. You can observe. Okay, from figure 2, what is the data given? Okay, you want V1, but I1 is 0 because open, but V2 is given 10 volts and no information about I2. I2 is not given. Getting all of you? I1 0, V2 0. You remember the parameters combinations. When you define I1 0, V2 0, I think you define H parameters. Yes or no? What are the equations of H parameters? So this is how you have to think. H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. This is equation 1 and this is equation 2. When V2 is 0, you will define H11 H21. When I1 is 0, you define H12 H21. Sorry, H12 H22. Is that all of you? Okay. So therefore, I'm intentionally taking this H parameter equations because in the given two figures, we understand that in the first figure, V2 is made 0. In the second figure, I1 is made 0. Okay. So from that, I understand, okay, H parameters information is given. Okay. H parameters information can be determined easily. Of course, when I1 is 0, you can also find Z22, no doubt. But here V2 is 0. So I cannot relate again here. That is why H parameters is more suitable to deal with. So reciprocal. What do you mean by reciprocal in terms of H parameters? H12 is equal to minus H21. So when I1 is 0, from the figure 2, you can understand from figure 2, when I1 is 0, look at this, when I1 is 0, what do you get here? V2 and I2. When I1 is 0, V2 and V1. Some relation you are getting already. So H12, when I1 is 0, okay, when I1 is 0, you can find H21. From 2, if I1 is 0, then I can find not I1 0, but V2 0, because H21, H12 can be determined. Here, once I find H21, I can find H12, or once I find H12, I can find H21. So from 1, I understand. Let me write like this. It's more easy. From 1, when I1 is 0, okay, H12 is equal to H12 is equal to V1 by V2. V2 value is known. V1 can be determined if I know H12. But I do not know what is H12 here. Yes or no? But I can find H21 from this 2. Okay, you call it equation 3. From 2, if V2 is 0, I can find H21. Look at this. H21. What is that? I2 by I1. What is I2 actually here from the first figure? Because when V2 is given, the data is given here. What is that value? 10 by 2. I2 by I1. Okay, 10 by 2. This is 5. 5. That's it. 5. So say this is 4. But you know, H12 is equal to minus H21. That is nothing but 5. But this value is V1 by V2 is equal to minus 5. From this, you find V1 is equal to, what is V2 here? Yes. What is V1 by V2? Minus 5. Then you find what is V1. Minus 5 into 10, that is 50. Minus 50 volts. Please note down. Please note down that. I think we did a small mistake here in the calculation. What is I2? 2 amperes. I1 is 10 amperes. So I did, I think, mistake. So this is 2. This is 10. So this is 1 by 5. So you got minus 1 by 5. You got minus 1 by 5. So what did you get here? Please correct it. Okay. The next one. Please note down. Meanwhile, I just write another problem here. 20th problem. 20th was asked in GATE. It's a very simple. If you can try this, I'll directly give the answer here. D is equal to 3 by 2B is equal to 4 by 3C. Then what is Z11? Then what is Z11? Let C is equal to 1. From this, you understand A is equal to, D is equal to, C is equal to 1. 4 by 3. C is equal to 1. Then A is equal to D is equal to 4 by 3. And B is equal to, then what do you get here? 3 by 2B is equal to 4 by 3C. So it will be like 8 by 9. Okay. So already C is equal to 1. So A, B, C, D values are given. So what is the transmission matrix here? You got 4 by 3 and 4 by 3, 8 by 9 and 1. This is what you got. So you find now Z11. Z11 means Z parameters in terms of ABCD parameters you are supposed to find. You know how to express Z in terms of ABCD. You already found ABCD in terms of Z. So now you have to apply the same procedure. Okay, you write the equations of Z, you write the equations of ABCD. Don't change these parameters, these particular equations. Okay, you change only these equations, and the resulting equations must be looking like same as Z parameters equation. Then you compare. Okay, then I'm giving you as an assignment to you. You can solve it. You can do it. Okay, so otherwise I'll just give you quickly Z11 I1 plus Z12 I2 equation A. V2 is equal to Z21 I1 plus Z22 I2 equation B. So don't change these, but ABCD parameters V1 is equal to AV2 minus BI2 equation 1. I1 is equal to CV2 minus DI2 equation 2. Okay, you want Z11. So first you need to compare these two, but what is happening? V1 I1 I2, but V1 V2 I2. You are supposed to eliminate this V2. For this, what I do is, from this equation, can I find V2? V2 is equal to what? 1 by C I1 plus D by C I2. That you substitute in equation 1, then entire equation will be converted into what? Okay, in terms of V1 is equal to something into I1 plus something into I2. Then if you compare this equation A and that resulting equation after substituting this, okay, so I'm writing here from 2 you find V2 is equal to something into I1 plus something into I2. You call it 3. Now 3 in 1, if you substitute, V1 is equal to something into I1 plus something into I2. That's it. So this is 4. Now this 4 and equation A are compared. Understand? Okay. From 4 and equation A compared, this is nothing but Z11. I am directly giving the answer here. Z11 is equal to, you got 4 by 3 ohm. So let me check once again here. Z11 is equal to 4 by 3 ohm. That is an answer here. Okay. Understand all of you? So please note down this. You have to do this work. That is 20th problem. Now let us move on to 21st problem. So 20th problem was asked in GATE and 21st is also. So these problems I won't solve because you can do it. I've already done similar cases. I just want to let you understand how the GATE problems are given. But already we made a lot of discussion on the similar cases. So transmission parameters are given. Here is asking what is the input impedance. Transmission parameters are given. What is Zin is asking. So I just again give you answer 12 by 13 ohm. Please note on this. You try this. How do you try? Volt-amp method. Yes or no? According to Volt-amp method, what will you do? You connect a source across the terminals where the impedance is required. Inject some current I1. This is V2. This is I2. Yes or no? You write the equations, transmission parameters are given. Okay, A V2, that is nothing but V2 minus B I2, 2I2, equation 1. I1 is equal to C V2, that means V2 minus D I2, 3I2, right? And what is V2? V2 is equal to minus 10I2. You want V1 by I1, right? So V2 you just substitute here, minus 10I2 here. I think you can do it easily. So if you substitute 3 in 1 and 2, then what do you get here? What do you get here? V1 is equal to minus 10I2 minus 2I2, nothing but minus 12I2. And I1 is equal to minus 10I2 minus 3I2 minus 13I2. Yes or no? This is 4. This is 5. 4 by 5 will give you Zin, nothing but V1 by I1, nothing but 12 by 13 ohm. So I already solved it. Okay. So you can also solve it. Easy problem. Very simple problem. 22nd problem. We can move on. Please note down that quickly. We can move on to 22nd problem. This was asked in GATE. A dependent source problem it is. In case of dependent source problems, usually how do you solve the problems? Use either mesh analysis or node analysis. Okay. 10 E1, this is plus minus E2. It is given as I2. It is given as 2 ohm and this is I1. This is plus minus E1. That's it. So he's asking what is Z11 and Z21. Z11, Z21. When Z parameters are asked, better you apply mesh analysis. This is I1, this is I2. So this is the dependent source. He has not given the symbol of dependent source, but he is mentioning 10E1. Sometimes he doesn't give the symbol, but he will mention 10E1, 10E2, something like this. So you understand that is a dependent source. Okay. So what do you get here? E1 is equal to first loop. First loop when you write, so 2I1 plus this value is given 4 ohm. This is 4 ohm. Please note it down. So he's asking what is Z11, Z21. So plus 4 times I1 plus I2 plus 10E1. This is equation 1. Second equation, E2 is equal to 4 I1 plus I2 plus 10E1. That's it. So rearrange these equations and then compare with the standard equations of Z parameters. You can get the values. This is a simple job. So I'm giving you directly the values here. The values here. So what do you get here? You will get 12 by 11 minus 10 by 11. 12 by 11 minus 10 by 11. You can do. Okay, I'm not solving because very simple. Okay. You can spend some time to get the solution, I'm telling you. In exams, accuracy is very, very important. You can't do silly mistakes in the calculation part. So you need a lot of practice. Twenty-third problem. Which was asked in GATE. It's another simple. Z11, Z12, Z21, Z22. This is one more. Find the overall Z matrix. Find the overall Z matrix is asking. Let me remove this part. This is also very interesting. Find Z22. 1 dash, 2, 2 dash. So 4 options were given actually here. Option A was nr by n minus 1, B n square r by n minus 1 whole square, C n r by n square minus 1, D n square r by n square minus 1. So 23rd problem is very simple. Okay, is asking overall Z, but Z parameters were given. You know that there is a relation between T model and Z parameters. Yes or no? If a T model is given, I can easily determine Z parameters. If a Z parameters are given, I can construct an equivalent T model also. So if I assume that there is one T network in this, so what is that extra element connected to here? This is ZA, ZB, ZC, let us say. Let us assume that for a given Z11, Z12, Z21, Z22, I found these values. Based on these values, I constructed this network, let us assume. Understand? Now it's very clear that if I assume that there is a T, this 1 ohm is connected to what? ZA only. So according to our inspection method, the overall Z in this, which one will be affected? Only Z11. Yes or no? Because Z12 doesn't contain this ZA at all. Z12 is nothing but ZC. Z21 is nothing but ZC. Z22 is nothing but ZB plus ZC. That means ZA is not come into picture. ZA comes into picture only in Z11. Therefore, now this is modified. This will become 1 plus ZA is nothing but now the ZA in the new or overall two-port network. Therefore, you will get, okay, you will get only Z11 is getting modified. Therefore, Z11 plus 1. Z11 was ZA plus ZC, but now it is becoming plus 1. Therefore, Z11 plus 1. What is Z11? Z parameters of the two-port network given in this box. So, therefore, Z22, Z12, Z21. It's very simple. This simple modification will give you the overall two-port network. Okay. Now, coming to this one, 24th one. So, I think you understand this, right? If I assume the T model, it's very clear. Only this Z11 is affected. That's nothing but Z11 plus 1. Okay, you will get. Right. Now, the question in the 24th problem, which was asked in GATE, what is Z22? An ideal transformer is given with 1:n ratio, turn ratio, one resistance connected between 1 and 2 port terminals, between 1 dash and 2 dash, 0 resistance wire is connected, is asking what is Z22. Okay. So, whenever impedance is asked, we have only one option, that is old-time technique. Input impedance or output impedance, whatever is asked. We are left with only what? We are left with what? Only old-time technique. Because how do you define Z22? Z22 is nothing but V2 by I2 when I1 is 0. Let me apply the same conditions here. So, okay. So, let me connect. This is nothing but output impedance under the condition I1 0. Okay. So, let me connect. This is plus minus V2 and here I am injecting I2. This I1 is made 0. Otherwise, I can't define what is Z22. This voltage is V1 I can define and this voltage is already I know V2. Okay. And this I2 is getting divided. This is Ix, let us say this is Iy. This Ix is coming plus I1 is coming, but I1 is already 0. Therefore, this is also Ix. And this Ix is coming. Since it is open terminals, the same Ix is coming here. Yes or no? This is also Ix. Up to these 2 points or this particular point, this Ix is coming. But Ix and Iy both are again becoming what? I2. So, KCL if you apply, so you will get I2 is equal to Ix plus Iy. Equation 1. Yes or no? The dots are given here. The 2 dots are given in the question. Please check that. Okay. If the dots are not given, default dots can be taken like that. And another relation you will get. Some relations you need to obtain so that you finally express V2 is equal to something into I2. That something is nothing but Z22. Under the condition I1 0, you are finding V2 is equal to something into I2. So that I am supposed to determine. Okay. Just from the definition of Z22, I am finding all these things. Okay. I can't really apply stability transformation. I can't go for mesh node analysis here. It's not possible for me. So I can apply the definition directly and find the value. Now, can I do V2 by V1? What is V2 by V1? Is nothing but n by 1. Can I do Iy by Ix? I can't take I2 by I1 because what is the current flowing in the primary winding and current flowing in the secondary winding? I2 is not the current flowing in the secondary winding. Iy is flowing in the secondary winding. But what is the current flowing in the primary winding? Ix is flowing. So I can relate only Ix and Iy. This is an ideal transformer. Okay. So I'll get 1 by n, but Ix should enter, is entering. Iy should leave, but it is entering. Therefore, there is a mismatch. Therefore, minus sign. Okay. I get another relation, I guess. This is V2. This is V1 because it is shorted. If I assume that this is 0, so this is also 0. Yes or no? So what is this voltage? V1. This is V2. V2, V1, but R is there. Ix can be related here. Ix can be written as V2 minus V1 by, what is this? Capital R. Understand? So if I substitute 3 in 1, then I2 is equal to ix, but iy is equal to minus 1 by n ix. Yes or no? Iy is equal to minus 1 by n ix. So already ix is there. So I can write it as what? N minus 1 by n ix. So let me call it equation 5. Clear all of you? Okay. Let me call it equation 5. If you substitute 2 in 4, I get ix is equal to V2 minus, because I am interested in V2 and I2 relationships. So let me try to avoid or eliminate V1 here. So what is V2? What is V1 actually here? V1 is nothing but V2 by n. So V2 by n by R. So can I write something like this? N minus 1 by n into V2 by R. You call it equation 6. Understand all of it? Okay? From this 5, can I express this ix is nothing but n by n minus 1 I2? Yes, I do. I call it equation 5. Now I eliminate. This entire equation is having ix and v2, but now ix is in terms of I2. If we can express, then entire equation will be in terms of I2 and v2 only. So equation 5 in 6, if you substitute, so what do you get, Nana? N by n minus 1 into I2 is equal to n minus 1 by n into v2 by r. So you get v2 by I2, then n square into r by n minus 1 whole square. So this value is nothing but what? Z22, because you already applied the condition I1 0. So Z22 is nothing but n square r by n minus 1 whole square. Second option is correct. It's a very interesting problem. Please note on that. Everything comes from the method 1, method 2, method 3. How to find the parameters? I explained you 3 methods, method 1, method 2, method 3. Depending upon the context you are supposed to apply. Is asking Z22, then Z22 definition itself is saying that I1 0, V2 by I2. It's nothing but output impedance. Output impedance under the condition I1 0. How to find the impedance first of all for any two-port network? It is old-time method only. That is why V2 and I2 have injected here, and then I found all these values in terms of n only. Now let's look at a simple topic, network functions. Okay, network functions. This is one port network as domain network. Network functions are nothing but the parameters in S domain. Okay, I define what are the network functions clearly. Say this is V1 of S, this is I1 of S, or else V of S, I of S you can take. This is V of S by A of S. Y of S is equal to I of S by V of S. These are called input impedance and output impedance. We call, because they are all in S domain with all initial conditions set to 0. Because S domain you can construct only with an assumption that all initial conditions set to 0. Network functions are defined with an assumption initial conditions are 0. If you take two-port network, S domain two-port network, that means you are expressing all elements in S domain. This is V2 of S, this is I2 of S, this is I1 of S, this is V1 of S. So all variables and network constants and parameters will be in S domain now. with an assumption that what? Initial condition 0. Otherwise, you can't define network functions, I'm telling you. Okay, network functions are defined under initial conditions set to 0. Now you define certain terms here. Number one. Driving point impedances. You call it Z11 of S is nothing but V1 of S by I1 of S when I2 is equal to 0. This is called driving point input impedance. Please note down V2 of S by I2 of S when I1 is 0. Driving point output impedance, you call it. Okay, we have some names for network functions. Driving point input impedance, driving point output impedance. Okay. Transfer impedances. Transfer impedances. Z12 of S, so V1 of S by I2 of S when I1 is 0. This is called transfer impedance. Z21 of S is V2 of S by I1 of S when I2 is 0. So these are called transfer impedances. Okay, one is a forward transfer impedance, the other is reverse transfer impedance. Third one is driving point admittances. So Y11 of S, I1 of S by V1 of S when V2 is 0. So driving point input admittance. Y22 of S is I2 of S by V2 of S when V1 is 0. Driving point output admittance. Transfer admittances. Transfer admittances. Y12 of S, I1 of S by V2 of S when V1 is 0. Y21 of S is I2 of S by V1 of S when V2 is 0. So these are called transfer admittances. Voltage gains. Alpha 12 of S, V1 of S by V2 of S, or alpha 21 of S, V2 of S by V1 of S. Current gains. Beta 12 of S is nothing but I1 of S by I2 of S. Beta 21 of S is nothing but I2 of S by I1 of S. Current gains. Like that you can define in S domain, all the values are defined in S domain with all initial conditions set to 0, then you can define all these network functions. These are all called network functions. Z11, Z12, Z21, Z22, Y11, Y22 and so on. Okay, so please note down. A simple example I would like to take, 25th problem. 25th problem. One farad, 1 ohm. You're asked to find Z matrix. 25A. Twenty-sixth. It's a ladder network. Z1, Y2, Z3, Y4, Z5, and so on. Driving point input impedance. Let me remove this. You have driving point input impedance, driving point input admittance, output impedance, output admittance, transfer impedances, transfer admittances. All of those values can be determined in S domain with all initial conditions set to 0. Clear? So the first important point to be observed that you have to convert everything into S domain. So it is 1 farad, so 1 by S ohm. It is already 1 ohm. It is also 1 by S ohm. So what is Z matrix you get? Tell me. First convert everything into S domain with all initial conditions set to 0. When initial condition is 0, capacitor can be replaced by 1 by S. That's it. So add these two, you'll get 1 by S plus 1. Add these two, 1 by S plus 1. Okay. So this value is 1, therefore 1 and 1. So you got S plus 1 by S, 1, 1, S plus 1 by S. This you will get. Clear? We can do many problems like this. You give me any network, I can do. Only thing you have to convert everything into S domain with all initial conditions 0. Understand? Same procedure you can apply. Star delta transformation you can apply. Simplification part is same, but in terms of S, you are going to get the values or the answers. But now the driving point input impedance of a ladder network, which is going up to infinity, let us say. Okay, it is going up to infinity, let us say. So it's a ladder network. A ladder network is given. Then I'm interested to find the driving point input impedance. I'll give you directly formula. The derivation is not that important, but you have to remember this formula. Okay, how do you find the driving point input impedance of a ladder network? Z1, Y2, Z3, Y4, Z5. See 1, 2, 3, 4, 5 and so on. Remember, when ladder network is given, when you are planning to answer or when you are ready to answer the question that is driving point input impedance, make sure that these are all series elements, all are in impedance form, that is ohms, and all shunt elements must be in Siemens. This point you must remember always. Okay? Because in the exam he will give you all in ohms or all in Siemens, we don't know. Okay? Mostly they will give all in ohms, but you have to convert these shunt elements into Siemens, otherwise the entire problem will be wrong. Okay? So 1, 2, 3, 4, 5. Z1, it's not Z2, it is Y2. Z3, it's not Z4, but it is Y4. Z5 and so on. So Y6, Z7, Y8 like that. So, okay, 2, 4, 6, 8 like that. The formula is something like this. Driving point input impedance Z11 of S is equal to, first you take Z1 plus, understand? Okay, 1 by, that's very clear. Here only I am taking. Next immediately Y2 plus, but you draw a line here. 1 by, next one is what? Z3 plus 1 by, it's not Z3, yeah, Z3, right. Then Y4, yes, here 1 by Y4, Z1 plus 1 by Y2 plus 1 by Z3 plus 1 by Y4 plus 1 by Z5 plus 1 by and so on. You understand all of you, okay? This is what the formula you are supposed to use. Be careful. Z1 plus 1 by, Y2 plus 1 by, Z3 plus 1 by, Y4 plus 1 by, like that you are going to take. Okay, I'll give you an example of it. 27th. Just an example. I'll give you. So let us see. This is 1 Henry given. 1 Henry. For convenience, we are taking all ones, okay? 1 farad and 1 farad. So expected to find here Z11 of S. That means driving point input impedance. Driving point input impedance we are finding now. So please note down that formula. Let me remove this. So I told you when the ladder network is given, if driving point input impedance is asked, okay, if driving point input impedance is asked, then how do you deal with that? Look at this. First, you make sure that all are converted into S domain. So this will become what? S ohm, 1 into SI, right? So S ohm, this is 1 by S ohm, but it must be, shunt elements must be in Siemens. Okay, S Siemens, 1 by S. So this is 1 by S ohm, but I want in Siemens S mos. Okay, so this is 1 dash, 2 dash, like that. So now you want to find Z11 of S. So what is Z11 of S? First S plus 1 by. Next one is what? S plus 1 by. Next one is what? S plus 1 by. Next one is what? S. That's it. There ends the matter. Right? Now if you simplify, this is S square plus 1, but this S goes here. So S plus 1 by S plus S square, sorry, S by S square plus 1. So this part I have simplified. I've got this, right? Okay. Now if I simplify this part, I'll get this. S plus 1 by S cube plus S plus S. Yes or no? S cube plus S already, but this will go to the numerator. So this will become S square plus 1. Now again I take LCM. S power 4, this is 2S into S. So 2S square plus S square plus 1 by S cube plus 2S. Nothing but S power 4 plus 3S square plus 1 by S cube, okay, plus 2S. So this is what very, very important. Understand all of you, okay? So that will help you a lot. The formula will certainly help you a lot to determine driving point input impedance of a ladder network. So this is very important, but make sure that all are in Siemens shunt elements and series elements are in ohms. Okay, this is Siemens and this is ohms. Please note down that. Meanwhile, I just give you 2 more. You can work out at home. Find Z matrix. I directly give the answers, okay? 29th. You work out at home. Find Z matrix of it. Oh, transmission matrix. Find transmission matrix. I'm sure that it will take a lot of time to find the transmission matrix. So usually these network functions are very much useful in network synthesis part. So what is the Z matrix? Here transmission matrix, ABCD parameters, whereas here Z parameters. So first you convert here. This is 1 by S ohm. This is 1 ohm, 1 ohm. This is 1 by S ohm. That's it. So what will you do here? You can convert this into T model. Yes or no? T model. How do you find T model here? Let me find here. 1 into 1 by 1 plus 1 plus 1 by S. So what is the denominator here? 1 plus 1 plus 1 by S. That means 2 it is. So 2S plus 1 by S. 1 by. So this is 1 plus 1 plus 1 by S. Nothing but 2 plus 1 by S. Nothing but 2S plus 1 by S. 2 plus 1 by S is nothing but 2S plus 1 by S. Right? This is what the denominator need to be remembered. So finally answer will be like for this particular one S by 2S plus 1. Right? But what about this? 1 by S into 1 by 2S plus 1 by S. S's get cancelled. So 1 by 2S plus 1. This is also 1 by 2S plus 1. So what is that matrix of it? What is that matrix? You already have this 1 by S plus this. That means this total can be added. So Z matrix will be something like this. You see 1 by S plus 1 by 2S plus 1. And whereas here you can see these two can be added. That is 1 by 2S plus 1 plus S by 2S plus 1. Now this will become S by 2S plus 1 and S by 2S plus 1. Right? Okay. So this will be 2S plus 1 plus S by 2S square plus S. S by 2S plus 1. Okay. S by 2S plus 1. So this is 2S plus 1. That is S plus 1 already. Okay. So S plus 1 by 2S plus 1. Okay. So transmission parameters when you find, I give you directly that answer. Okay. You simplify it. What will you do here is, first you find Z parameters. How do you find Z parameters? Okay. So mostly in GATE, such lengthy problems may not be given because it takes a lot of time to simplify. But in IES, in a descriptive model, it may be asked in any question. Okay. So I'm just giving you an example to understand it. First, you experience it first. Okay. The calculation, how it goes, if you experience, nothing wrong in that. You will come to know what is happening in the calculation part, and you can realize how you calculate in S domain also, how you calculate transmission parameters. So first you find Z parameters, right? Then you find transmission parameters in terms of Z parameters. You express, then you will get T. Okay. So I'll directly give transmission matrix T of S S square plus 10S. Okay. I just give you 1 by S square plus 6S plus 8 of S square plus 10S plus 8, 3S square plus 4S, 2S plus 12, S square plus 8S plus 8. The denominator is same. Okay. That is for the 29th question. Okay. So, students, this is how you can see the two-port networks. We have covered almost different varieties of problems. We did not leave in a single model in this. We covered in network functions, we covered in theorems, we covered in many other dependent source problems, and we covered several models here. So this is how you can expect the two-port networks. So go through the concepts clearly. You can definitely solve any problem that you come across. It's an easy topic and scoring topic. Magnetic coupled circuits and two-port networks, okay, network topology, all these stuff, filters, okay, filters, they're all scoring topics. If you get any question, you should not miss it, I'm telling you. You must score, whatever the problems are given, you must score 100% in that questions. You can't do any mistakes also. Because scoring, because everybody will do. If you don't do that, you're going to be on the loser end, okay? So, this is finished and we see in the next sessions.